volume, smallformfactor.net's podcast. My name is Josh Ramirez, and today I am joined by James. James, how you doing?
I'm feeling a lot more awake this time, so that's good. So hopefully I'll be able to keep up with the topics.
Well, we'll get used to it. We'll get used to it. I'm also joined today by John Morrison. John, how are you doing back down there in New Zealand?
I'm not baking this time. It's great.
I believe you explained it's now 28 degrees instead of 30 degrees.
That 2-degree drop makes all the difference.
I'm sure. And I'm also sure I have no idea what that difference is, given that I don't know Celsius. But that's okay.
It's 2 degrees is 2 degrees, it seems.
Fair enough. And finally, we're joined today by Jay Mattison. Jay, how you doing in Philly?
I'm doing great. I've slept very well.
That makes you and James and maybe John. I don't know how well John slept. How well did you sleep, John?
Not good.
Okay, great. So that makes the two of them. All right. So before we get into the news, one thing I wanted to mention, since it's something we decided a bit last minute, but we're actually going to start doing moving forward with all our recordings for our podcasts, is for premium members on the forum, premium members and premium membership and subscriptions being something we talked about during last episode. One feature that we're now introducing is that they'll be able to join us on the podcast insofar that they're going to be able to sort of listen live as we record and talk about these things, and B, we'll also, as we almost always do anyway, have a bit of an after show where we kind of shoot the breeze, talk about things related to the show or other things that are going on in our lives, and we'll let people listen in and participate on that. So if you hear us referencing people in the chat, just know that it's people that are sort of joining us live, and they can sort of type up notes and contribute feedback, instant feedback from listeners, and it's all well and good. All right, well, let's go ahead and get started and just jump right in. We've got a fair amount of news to cover, and I'm actually going to start with the thing that I think you guys will probably laugh at me, but I find it to be the most exciting and the most important thing we're going to be discussing today. And that is that SilverStone has actually announced a new SFX to ATX adapter bracket that's relatively inexpensive. And the thing that's special about it is that it doesn't orient the SFX power supply within the ATX sort of area or space to be completely centered. It actually aligns it like against one side, which ostensibly makes way more sense, but actually James is going to have you elaborate a little bit since you wrote the article for the news site.
Yeah. So what it is that, like, the main reason that I would see that you would want to use a SFX power supply in a case that can normally take ATX is like all those, like Lian Li makes some, Johnsbow makes some, I think SilverStone makes some, SilverStone definitely makes some, where the power supply is above the motherboard, and so it limits the CPU heatsink height. And because a ATX power supply is 86 millimeters in height, while SFX is 63.5, so you can gain a little over 20 millimeters by switching to SFX. But if the power supply is centered, like basically every adapter bracket that's been made so far up till now, you're only gaining about 10 millimeters instead of the 20. So I really don't know why it took so long, but we finally have a bracket, because I've seen people ask about this for like a year or two now, like about just making one or making one themselves or something. Because this way, with it offset, you can maximize the height that or the space that you gain by switching to SFX to get a bigger CPU heatsink in there. So it's really, really nice that they've finally done it, and it's really, like I said, it's very affordable too. They're not gouging anybody on this thing either, which is really nice to see.
Yeah, in the article itself, you specify the MSRP is actually $6.71, which is, I mean, for something like this, nothing. I think they could have easily charged like $15-20, and people would have just been like, well, they've got to make their money. It's still not much. I guess I'll live with it. But no, I mean, that's great.
Yeah, it's very reasonable. So I'm kudos to Silverstone for that. I'm really happy to see that.
Yeah, it's funny because like you see this, and then only then does it really occur to you that the fact that most of the other brackets centered the power supply within the opening is kind of stupid. Because like if you wanted to use SFX instead of ATX, like you're not really very few people are going to do that because they happen to have an SFX lying around and that was the only thing they wanted to use, right? Like most people are going to want to use that because they want the additional space. They want to use the smaller power supply. But a lot of that benefit is wasted if you're just like inappropriately putting it arbitrarily within that, opening or within that space that ATX normally would take up. So I'm surprised it took this long for this sort of a bracket to come out, but I'm incredibly happy that it's now available and that it's so inexpensive.
Yeah, and the other thing is that like with the centered ones, I mean you could flip it around, so it's not like it would make sense to have that in order to like for cooling or something. Like you could flip the bracket around either way. So yeah, I'm really surprised it took this long for somebody to come out with one, but at least it's here now though, so that's good.
All right, I'd like to move on to the next item we have in our notes, which is actually sort of a interesting dramatic debacle that I've been following for a while now. So a while ago, there were some motherboard manufacturers that were able to sort of unannounced out of the blue through firmware updates offer an ability for people to overclock Intel processors that were non-K Skylake. So with Skylake and with some previous generations, if you wanted to do any meaningful overclocking at all, you had to get the K version, which is usually more expensive. That unlocked a lot of the things like the BCLK and multiplier that would then allow you to, again, meaningfully overclock at all. But then it turns out that there was some loophole in the microcode that Intel provided to board manufacturers that made it trivially easy for them to enable effective overclocking with these non-K CPUs. And so a few manufacturers, I think Asus was one of them, Asus and ASRock I think were the main two, pushed out firmware updates that then allowed people who had bought these less expensive processors to do overclocking. Which at the time was itself interesting because it was basically motherboard manufacturers controverting the desires and orders and wishes of Intel. So many people are wondering when Intel was going to sort of respond to this. They actually just did fairly recently by, again, pushing out some new micropode to motherboard partners, effectively sort of plugging this bug or loophole or whatever you want to call it, and thus preventing people from being able to do this overclocking. I felt like this was just an important thing to bring up, if only because it's just sort of a curious thing where I'm not necessarily sure that this is really the right thing for Intel to be doing. And it's just sort of awkward in that like this whole episode really only highlights how arbitrary it is that Intel's sort of locking this capability on the cheaper CPUs that they sell. I mean, it literally just comes down to some lines of software that they impose this limitation. As far as we near can tell, it has nothing to do with even straightforward things like binning or more obscure things like architectural choices or implementation of designs used on the lower end of the spectrum. So I was just curious as if you guys had any additional thoughts on this. Honestly, I just found it very entertaining.
I've got a couple of thoughts that are both marketing related. One is all of these manufacturers advertised that they've got non-ZOC or something like that. I can't remember the exact branding. And now they've got to have to stop all of that, remove stickers from boxes, reprint all boxes, that kind of thing, reprint manuals, and all of that, just because Intel decided to do this. The other side of this is I'm wondering if this is a marketing exercise from Intel. Maybe the Skylake boards were not selling particularly well, and they thought, if we stop overclocking, all of the boards that are sitting on the shelf in shops right now are going to sell out, so that people make sure they get the old BIOS.
That seems like a little bit of conspiracy theory to me. Because I mean, like
I'm good like that.
Because the Skylake processors at least have been. You can't get a hold of them because I think a 6700K. I don't know if it is right now, but for a while there, it was going for like $420 because it just wasn't available. So I don't think it. I really can't see this being like an experiment to just move product or anything like that. That's to me that's just kind of crazy. But my suspicion is that there was just. I mean, my guess is that it was like a bug, and like whatever. There's just some flaw in the microcode that allowed the motherboard makers to just use clever coding to allow this. And my guess is that Intel, it's not. I mean, yeah, I mean it could probably be just like they want to sell you the more expensive processor. But it's. I think it could also be that like they just don't know the implications of like doing this and like what effect it'll have like on the longevity and reliability of the processors or something like that. Um, well, I would think there's like good technical reasons to not allow this since they didn't plan for it. Though whether they should, I guess it's also a question though, like just in general, like with the way they do it, so that only the K processors can really be overclocked. I mean, that's kind of another debate. But as far as this particular issue with the Skylake, it's just I don't think it's like a conspiracy or marketing or anything.
So Funks in the chat for the podcast made the important note that basic clock overclocking was actually only possible recently, since that was tied into both PCIe and PCH controller bus speeds, which translate into instability, I guess, at relatively small overclocks, at least before that change. But yeah, for the most part, I agree with you, James. I mean, I get the feeling that this was just a bug that some manufacturers chose to exploit because they feel like it would help with sales. Everyone understood this problem, and thus everyone started taking advantage. And Intel eventually had very stern conversations with all of these manufacturers and board partners behind the scenes after the fact, because it sort of broke down a lot of the barriers they had built to segment their offerings in a way that would maximize profitability, for lack of a better way of putting it. So, I think this is just a sort of an interesting, if not somewhat absurd, chapter in the history of being able to overclock Intel CPUs and how Intel's sort of spread out its product line, but unfortunately, it seems like it came to a relatively quick end, at least for those who have been looking to overclock on the cheaper processors for a while now. So the one other thing in the news that I want to talk about, now that we've talked about Intel for a while, let's talk about AMD. I saw a release from Tech Power Up. This was the day before. AMD Zen processors to feature SMT support up to 8 DDR4 memory channels. Apparently they were able to, or somehow managed to get, a CERN engineer to present on behalf of AMD in the upcoming Zen architecture. And Tech Power Up noticed that there was a curious slide in the slide deck used during this presentation that detailed some information that we were already familiar with in terms of Zen. So 14 nanometer FinFET process, 4% improvement for IPC compared to current generation. But the sort of new addition is that, hey, look, this will actually support up to 8 channels of DDR4, which is potentially a ton of memory. I think anything that's been announced up to this point on either platform, at least at the consumer end, has been limited to 4 channels. So I don't know. I honestly am not terribly familiar with this beyond that information. I didn't know if any of you guys had read the article or had seen this in other places. But that's certainly interesting, if only because normally that quantity of memory, like you have to get the uber expensive, server board and all of this, and to sort of have that on this baseline socket on this unified platform is certainly unexpected.
Yeah, that's very interesting. I'm not sure how valuable it actually will be in the long term, but it is very interesting that they have support for 8 channels. That's a ton of channels if you really think about it. Like you said, you really see that on server and workstation type boards, but really as a consumer, would you be utilizing that much RAM? I'm not sure.
Well, I mean, since it's a CERN engineer, because I mean, I don't. I mean, most people just think of CERN as the people like who will potentially make a black hole and kill us all. But the Large Hadron Collider generates a ton of data. Like, just every time they run the thing, it just generates terabytes and terabytes of information that they have to store. So CERN is actually has like a really cool setup to like house all this data. So they have like their own data center, and they do a lot of their own custom architecture to kind of run all this stuff. And so, like, to me, like, a CERN engineer talking about 8 channels and 32 cores almost certainly is on the server side of things. Like, so I mean, it may be a unified socket and stuff, but I still suspect we're going to see kind of a differentiation between like consumer stuff and then like especially like CPUs and then server CPUs. So like I really don't think you're going to be seeing like 8-channel 32 cores on like your just consumer stuff. It's almost certainly got to be like just the server side of things.
And I guess you could argue that it may be useful initially, if only because currently most DDR4 modules have around half the memory of sort of comparable DDR3. I mean, obviously it's still, much more expensive, but it could be just a matter of maybe people want the same quantity of memory, but they want it to be DDR4, and so they need twice as many modules, and so here you go. Could be as simple as that, but I don't know. It's just, again, we talked a little bit earlier about Intel and sort of arbitrarily drawing lines in the sand to segment the market. And, this was another way in which it was segmented. If you needed junk loads of memory or you wanted the fastest possible memory, then you typically were forced to go on the super duper high end because that was the only socket or the only platform that would support it. And it's just curious that is a dimension in which AMD decided to sort of, at least it seems, tear that wall down a little bit and say, no, this is a potential feature or functionality that we'd like to extend across all levels. So, good for them. Like, offering additional choice to motherboard partners and sort of down the line to consumers is great.
Absolutely.
I think for me, the more exciting parts of this, not so much the memory, is the 40% improvement on IPC, or instructions per clock, compared to current generation AMD CPUs. And the fact that, it's 32 physical cores, but they're also going to bring in SMT, or what we call these days hyperthreading. That's, 64 cores on a desktop socket, possibly.
Wow.
Scary amounts of heat. Think about it like that as well.
Well, that's the thing. They're dropping down to 14 nanometers, so it shouldn't be as bad.
Absolutely, yeah, hopefully. I mean, we'll see what the actual performance numbers are.
Yeah. It looks like most of the stuff is orientated towards like the Opteron lines, which are generally lower clocked, so they generally stay within the same TDP kind of range as
correct, but
the desktop stuff, so 125 watts.
Right. It is worth noting, though, I mean, 40% improvement in IPC is massive. Even on a generation-to-generation basis, especially nowadays. You could literally drop... That means if you had an identically clocked part on this new architecture, it's 40% faster. Or you could reduce the clock speed 40%, and it would be equivalent in terms of real performance. I mean, that's insane. Like, imagine you had a 2 gigahertz processor, and then you move to, like, a 1.6 gigahertz processor, and that's actually still an upgrade. So, for what it's worth.
Yeah, what I hope to see is, because, I mean, they make, I think AceRock makes a socket, like an Intel Socket 2011 V3 server mini ITX board. So, I mean, even if it is differentiated, like the 32 core and stuff is only like a server part, I really hope that, like, since like a lot more stuff's going to be on board the CPU now for Zen compared to the previous generations, I'm really hoping that we see a mini ITX, like, I don't know if they're still going to call it Opteron or whatever, but like an ITX Zen server board that we could pop in one of these 32 core processors. That would be that would make for a really, really interesting SFF build. So I really hope that that happens. That'd be cool.
So the last bit of news we have, which sort of goes actually more towards stuff going on in the forum, and I'll just do a brief introduction because it's actually something John's been working on. But we wanted to do a cooling discussion, for lack of a better categorization, in part inspired by this build that John's been doing in this InWin BK 944 SE case, which is a very, very small 12.5 liter micro ATX case, which, normally has a relatively poor cooling design, in part just because, it's so restrictive and all of this. But if you go to the forum thread that John's been running, which I'll link to in the show notes, you can sort of see his relatively creative and ingenious solution to this, at least temporarily, which is cut a hole and have a massive heatsink sticking out of it. But that sort of led into alternative designs and orientation of components within a case of sort of similar dimensions in space, and that by itself sort of led to this sort of greater discussion surrounding what cooling tends to look like in smaller form factor systems and what people tend to prefer and what's ideal and all of this. So rather than continue to talk about it, I'm just going to let John sort of take over.
Turns out I typoed in the notes. It's an InWin BK644.
Oh,
That's besides the point. It's tiny. The whole case is 12.5 liters, so it's about as small as you really can get with SFX and micro ATX. And because the case was released maybe about 5 years ago, the cooling design isn't the best, and I'm having issues. So as a bit of background, I'm running a 125 watt CPU, the FX8350 I keep going on about, a decent micro ATX motherboard, 8 gigs of RAM, a 110 watt, I think, R7360, and that's got gigabytes open air cooler, which doesn't help me at all, and just a generic FSP 300 watt power supply. Now, the CPU in this case runs fine. I think I've maxed out at about 60 degrees, but the GPU idles at about 40, maybe 50, depending on how warm it is in the house, which is not good. Now, really, I'd like to stay with air cooling, but water is an option. What is your guys' preferred?
Generally, I always say if you can fit water, use water, some sort of liquid cooling, because you can stably cool higher temps for longer without generating a lot of noise, and it seems to work best for me. Now, your case is very, very small, but you could get creative and potentially, if you cut out maybe the roof of the case or one of the sidewalls, you could fit in some water cooling, but you still might not have enough space to really cool both components.
So for me personally, I've found that earlier on in my PC building career, I tended to prefer the simplicity of both the simplicity and relative inexpense of just sticking on a non-reference air cooler. Usually you could get something in the neighborhood of like $40 that would perform admirably. You could overclock it a little bit, which was fine. And then, with water cooling, all-in-ones are still fairly new. The pumps were very, very noisy. There were lots of issues, like people would, have pumps that failed, or, sort of they'd leak, and it just wasn't good. So air cooling to me was clearly the way to go. I didn't want to build a custom loop because that was way too expensive and would require way too much effort. Nowadays, however, it's hard for me to come up with builds in which I wouldn't recommend, an AIO for, at least for the CPU, unless you're really, really focused on noise, or you really wanted to keep the cost down as low as possible. And even then, I think a lot of the time it would still kind of be the sensible choice. I just, for me, the benefit is that you don't have this hulking cooler over your motherboard, especially if you're looking to overclock, so you can actually see it. Also doesn't put a lot of weight on the motherboard itself, a lot of stress. You tend to be able to get much lower noise. Pump noises don't tend to be an issue if you're careful with which AIO you buy. And then with expandable AIOs, now it's actually a lot easier. It used to be if you wanted a loop to cool your whole system, you'd have to get all the parts separately and put it together, and it would be very expensive. But now you can get these expandable AIOs, which have everything you need. And if you want to add like 1 or 2 blocks, all you need to do is add 1 or 2 more blocks, and you're good to go. In fact, for my upcoming build, I'm anticipating that I'll probably end up buying an expandable AIO so I can cool both my CPU and my graphics. And, you know, that sort of a build is something that a couple years ago I would have never considered. I would have thought it was too expensive or too complicated. But this sort of integrates everything and makes it simple enough where I feel confident in being able to do something like that and enjoying the benefits of liquid cooling throughout my system.
Yeah, liquid cooling has come really far in a short amount of time, and it's only going to get better.
Yeah, for me though, like, I mean, actually, because I'm running a NZXT X41 on my rig right now, which is a thick 140 millimeter all-in-one. It's a really good all-in-one, actually. Like, it's because I've tested, like, I've only personally have really used this one, and then an H50 I had like several years ago. But here at work, I've gotten the chance to kind of work with quite a few different all-in-ones, and most of the pumps are too loud. But the X41, it's kind of weird. You can run it at 6 volt, and the performance is still good, but the noise goes down quite a bit. But the thing is that I mostly have the X41 on there because testing. It's easier because the case I have I have the X41 mounted on a hinged side bracket, so I can just pop the side panel off and swing it open and just get to the motherboard and plug and unplug stuff. So mostly I have it for that, but kind of my final build, like once I'm kind of just done, will be like a completely air-cooled. So I'm thinking like the Noctua C14S and then like a 980, well maybe not a 980, but whatever next-gen cards, just a nice air-cooled one. Because like I've kind of put up with it because I'm always testing stuff, but like I just can't stand a noisy computer. Like even like the X40 running at 6 volt, the pump is still too loud for me. And I mean SPCR, they don't review a whole lot of all-in-ones, but I mean they said the X41's about the quietest pump they've ever tested. And so if that's not good enough, I mean I really don't have much hope for any kind of anything else. I know some people, like when they do a custom loop, they'll like suspend the pump, or like they'll like kind of enclose it in foam and stuff, but I don't really have space for that. So to me, like personally, I think it'll just always be an air cooled, just because that's the only way. If you want true silence, that's really the only way you can get it. Because I mean, like you just with a water cooled setup, you'll just always have a pump. But also it's just easier because like a custom loop's just kind of a pain if you want to swap parts out, which I have a bad habit of just kind of swapping, especially video cards. I just kind of swap video cards around. So like a custom loop would just make that a nightmare. So for me, I don't know, either air or if I have to, just an all-in-one.
How about you, John?
I do much prefer air just because like James, I do chop and change my system all the time. I move it around all the time, and that kind of thing. Plus, air's so much cheaper, and I'm on a tight budget. So, if I was going to water cool, it would be based on a basically modified all-in-one cooler.
Yeah, and that's a good point too, because entry-level AIOs tend to cost as much as like pretty high-end air coolers, and even mid-range air coolers, which are like half the price, tend to match performance, at least of entry-level all-in-one loops. So water cooling, even with that hardware, even with the integrated like works out of the box stuff, that ostensibly is a lot cheaper than building a custom loop yourself. Even then, the value proposition is not quite there until you get into more expensive bits. So.
Yeah, I mean, I spent $10 on my case, so I'm not expecting to spend over $100 on cooling it. But I may have to, because I think my main option here is going to be a larger air cooler for the graphics card. So as I said, the CPU is running fine. It's quiet. What do I have on it at the moment? I think I've got a Pelican Samuel and a Noctua fan on it. and it's got absolutely no problems with heat whatsoever, and this is with a 30-degree ambient. But the graphics card's just not coping.
Celsius, correct?
Celsius. We don't measure in black and white here.
So one thing we should all have like ready to use at our disposal when we're recording our show is a Fahrenheit to Celsius converter.
Yeah.
Because we all reference temperatures, and then all of us like smile and go, "Yep, that's right." I have no idea what that actually means, but
Well, the biggest problem is that like computers, like both in the U.S. and everywhere else, is typically referred to in Celsius. But then you talk like room temperature and stuff like that, then like the Americans are using Fahrenheit, which is where it gets really confusing.
Yeah. We kind of do whatever we want. So it'll be Celsius or Fahrenheit, really depending on how we feel that day, basically, as Americans.
Metric system.
wake up on a cool, misty Sunday morning. Today is a Celsius kind of day. Put up the Celsius wall thermometer clock on the.
And Jordan apparently works in Kelvin.
Oh, Kelvin.
Jordan in chat. Yeah.
Very interesting. I have no comment for that.
Oh man.
The other question I had for you guys is, do you prefer better performance or low noise? What's your priority if you could have one or the other?
Oh, for me, that's easy. Performance. I mean, the vast majority of the time when I'm using my computer, and right now my computer's just a laptop, and it's fairly quiet even at load, but when I had a desktop, and even with my laptop, when I'm using it, 99% of the time I have headphones on. So the noise really is one of the lowest concerns, if only because it's always going to be isolated in use. I mean, now granted, I don't want like a jet turbine of a computer on my desk. I'm sure there's some limit where, headphones aren't going to do too much. I'm just going to hate myself. But, I think it's pretty easy nowadays to have high performance and like acceptable noise. Maybe not like super quiet, but like, within the realm of, okay, like you'd expect to hear this in the background anyway in most homes or offices or whatever. So, just due to the nature of how I use my computer, performance tends to be the utmost consideration.
Yeah, for me, I mean, like I said, I prefer low noise. Though what I do is that I don't really sacrifice performance, I sacrifice temperatures. So like what it is I have, like I said, I have the pump on my X40 run running at 6 volts, and then I have the fan profile for the fan set, even like at like 70 degrees, I still have it set to only like 60-70% fan. And so, I mean, it runs fairly high temps, but I mean, some people, I mean, and this is probably another topic, is that there's a lot of people who just seem to chase low temperatures as just the end all be all of like having a high end computer, when to me, if it's not thermal throttling, to me, then the temperatures, it could be like 70 degrees and that's fine. Some people will probably hate me for that, but like I run my CPUs like 70, 80. I was testing something the other day and I hit 100 for a while. And that's Celsius. Wow. But to me, like,
Oh my god.
I mean, I'm not going to run that for long periods of time. I mean, that's only like 10, 15 minute test runs. So, I mean, I know that's not going to kill the processor, at least on an Intel board. So to me, like, running at 100 degrees, that's not a big deal. And so even running at like 70 degrees for somewhat extended periods of time, that's not a big deal to me either. But it's just kind of a...
Yes, for you Intel people.
Yeah, that's true. But it's just, it seems like a lot of people just have this idea ingrained that you just, like 70 degrees, your computer's just going to blow up. Like you have to have it like 50 max or something. But to me, I find that that's really not true with modern processors.
No, I couldn't agree more, and I'm actually really happy you make that point, because the thing that drives me crazy about it is this fixation upon lowering temperatures as much as possible under these false pretenses of like, well, that will improve performance if I get it from 60 to 50 degrees, or that'll meaningfully improve the longevity of the part or whatever. And it's like, you're wrong. And so you're making all of these sacrifices in other areas that are actually going to affect how useful your build is and how much you enjoy it, because you're basically lowering this digit that isn't actually going to improve anything meaningful in your life, right? So like, people, maybe they're spinning their fans way faster than they need to because they're trying to get the temperature down. Maybe they're having to live with a much noisier build than they otherwise would if they were comfortable just letting their CPU maxed out full throttle go at 70 Celsius, which by the way is well within the guidance that Intel and AMD both provide for thermal maximums that your parts are allowed to get to on a consistent basis. I think it's closer to 80 degrees Celsius in CPUs and closer to like 100 degrees Celsius on GPUs, at least on the AMD side. So yeah, I mean, there's certainly a benefit, especially at the really high end of those ranges of trying to get temps down a little bit. It is understood that if you exceed those ranges, that's when you start to be concerned about damaging the part in the long term and sort of reducing the lifespan from like 10 years to 5. But most of the time, people aren't really threatened or otherwise in danger of reaching these incredibly high temperatures. And it just annoys me that there's this attitude of like, the number one priority in a build when it comes to these components is to reduce temperature, get it as cool as possible. That's the best thing. No, like that is one dimension of many. And I think more often than not, it makes sense to sacrifice in terms of temperature and be willing to accept slightly higher temperatures if that means you're able to improve all these other areas that you are going to notice every gosh darn minute that you're using your computer.
Speaking of getting temperatures down, Jordan in the chat here posted his sensors on his current system. His memory is sitting between 80 and 100 degrees Celsius right now.
Wow.
That's cruel.
One memory stick is sitting at 93.5 degrees.
You guys are cruel.
Yeah, the difference here is his memory is FB DIMMs, so they're about 8 watts a stick.
Yeah.
And he's got 8 of them sitting right next to each other.
But, and again, like the hardware is rated for...
9 watts a stick.
The hardware is rated to be able to withstand that. And again, like, when in doubt for any of this stuff, which many people are, just look at the ratings that the manufacturers provide, right? Like, if Intel's providing guidance and they say that if you can get it to 80 Celsius or below, you're fine, then you really should only be concerned about temperatures if you're exceeding 80 degrees Celsius. Like, the difference to you as an end consumer and to Intel between, maxing out at 80 degrees and maxing out at 50 degrees is basically nothing. Like, there is no difference. So why would you prioritize trying to lower temperatures if you're within that range when you have to pay this very large cost in terms of like, okay, I mean, I have to spin my fans more, so it's going to be noisier, and there are all these other sacrifices and complexities. Maybe I'm not overclocking as much as I could, yada, 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 yada. It's crazy. It's crazy to me that people willingly sacrifice a bunch towards literally no end. I mean, they're controverting the guidance of the manufacturer that made the part they're using. It just makes no sense.
Though I will... Oh, go ahead.
The one thing I would mention is that all these mentions of like 80 degrees and 90 degrees, if you're on AMD, generally limited to 65 to 70 on your CPU. So keep that in mind.
Okay, and what I was going to say is that, I mean, it's a little different if you're overclocking, though, because when you're running at the higher temps, you're going to have a little bit more leakage in terms of like power, so it's going to consume a little bit more power. So at stock clocks, like on an Intel processor, I don't find that to be a big deal unless you're just right at the limit of your power supply. But I mean, if you're overclocking, I mean, that could definitely make the difference between like how high of a clock you can hit because of just the increased power, increased voltage, and so on. So I mean, there are use cases, and I mean, and some people just chase temps just to chase temps, which there's nothing wrong with that. I mean, we chase like small computers, just some of us, I think, have practical reasons for it, like just don't have room in your apartment or whatever. But I think a lot of us, it's just the challenge. So if that's what you're into, that's cool. But I think what I don't like is just people, like kind of Joshua was saying, is just sacrificing so much just to get low temps, even though they don't really need to, just because they don't realize it's okay to run it at higher temps.
Yeah, definitely silence over temps for me. Usually, if I'm doing a build, I'm prioritizing the silence first. I kind of build backwards. I look at what specs that I need. I try to buy something a little higher than that and make sure I can cool it properly, but that it's dead silent.
And so, like, how walk me through like what do you do? What do you buy? How do you build to sort of maximize the acoustic performance?
Usually, unlike most people, I tend to start a build with a case first. So I'll say, this is the case I want to use, whatever it is. Then I'll decide whether or not I can get the components I need into it. So if I say I need a 6700K, there are cases that are too small to support that simply because the heat would be unmanageable. But so for a case like that, I might go with, say, a 6700 if that meets my power requirements and it fits into the system and I can control the heat. So I would go with the 6700. Then I would look into water cooling first. Like I said earlier, I prefer water cooling or liquid cooling, whichever way you want to call it. But if a case is too small, like my build that you've all seen, I look for the smallest, quietest fan possible. So in my case, it's usually a Noctua cooler. They're excellent. They cool well, but you're not always going to get the lowest temps. Like my CPU doesn't run at 35 degrees, 28 degrees Celsius, but it runs at about a stable, 40 to 50 depending on what I'm doing, even under load, which for me is, like you all said, it's perfectly fine. It goes up to maybe 60, 65, 70 under if I'm rendering or something like that. But normally it's typically around 40 degrees. So for that use, it's perfect. And the system is also extremely quiet. If a fan has to be run for me, personally, over around 1200 RPM, that's too loud. No matter what it is, I don't want any fans in my system running over 1200 RPM. So that's usually the baseline that I look at. Can I run my fans at around 1000 RPM and still get the performance and temperatures that I need?
All right, so that covers it for news. I figured we'd wrap up today. As I mentioned during the last show, we're kind of doing this thing where every episode of the podcast we sort of pick out a thread that's popped up that's our favorite thread for that past 2 weeks or so. After numerous discussions and debates, we've decided that heretofore this section of the show will be forever called the Fortnightly Favorite Fread, or the Triple F. And for this episode, our favorite thread, which of course you can see, we'll link to in the show notes, is the Ono 3 Pelican 1430 to S4 Portable VR Workstation, which is a bit of a mouthful, but to sort of summarize what's going on here, we basically have a relatively new member of the forum building a portable VR workstation that is a backpackable solution that runs off of a battery. I believe currently they're targeting around 1 hour of usage without needing to plug into a wall or anything. And it's just this whole contained solution. You've got this relatively impressive build within an NFC S4 Mini, coupled with a battery to power it and a VR headset obviously hooked in so that you can play. And honestly, any explanation I can hope to give in terms of all the stuff that this person's been doing and all the work they've been doing and all the stuff they've been sharing, I just could not give it justice. I mean, this is one of the most insane mod/builds I've ever seen on any forum, let alone our own forum. And what's crazy to me is that the person who's running this actually asked them sort of later on in the chat whether or not they were electromechanical engineer or some such thing by trade. And no, like their knowledge of basically rewiring all these things and dealing with battery and power and voltage and wattage and whatnot. And they are self-taught, soup to nuts. And it's just crazy. I mean, it's still coming together. It's still very much a, prototype level build at the moment. But man, it's I just want to talk about it because it's just freaking amazing.
Yeah, The user is the name is LHL. They're just a genius. I can't even keep up with half the thread. It's above me.
I mean, seriously, some of the stuff and just talking nonchalantly, just like, oh, well, so I pulled the meter and I got these readings and therefore I need to pick a battery. Let's break down these long bolded lists. Batteries. Here are all the kinds of batteries: alkaline, lead acid, NiMH, lithium ion, lithium Fe, which is iron. So lithium iron. Apparently, that's kind of battery. And then let's break down each of these options, and then you have these like sub bulleted lists of all these things. So on the one hand, it's interesting just because of the complexity of the work, and like the end product's really cool. Like a self-contained VR solution that lets you play VR without hooking into a wall for an hour. That's awesome. But LHL does spends a lot of time sort of explaining a lot of things to idiots like me, or at least certain aspects of it that sort of really help to get you to appreciate the sort of complexity and work behind the decisions that are being made in terms of like, okay, this is the battery technology we're going to use because it makes sense in this context. Okay, here's the hardware I chose for this VR build because I wanted to really maximize performance to power consumption, and the way I'm hoping to use this and make it portable in this way, it just made sense. Or here are all the discrete components that are going to come together to make the cohesive whole of a technology solution that allows you to play VR in a portable context. I mean, it's just supremely interesting and super cool.
Yeah, I'm always one for doing a mod, but this is next level. This is, like you said, one of the coolest things I've ever seen by far. I never even would have thought to try to do a portable VR rig, but kudos to him because it's really, really cool.
Yeah, and portable VR is going to be awesome because I think I've owned an Oculus Rift DK1 and DK2, and I have a CV1 on order, and I think John recently got to try out one of the Rifts, and like VR, like the current VR is like amazing, but being able to like walk around a room just like without a cable tethering you back to like a tower, that's just going to be awesome. So that he's able to get kind of like because I mean you can do that with like your VR because it's just using a phone, but you lose a lot of like the fidelity of like the graphics and the positional tracking that you do with like the full headsets, like the Valve Pre and the Oculus Rift. So being able to get that experience in a portable solution is just amazing. It's so cool that he's doing this.
I wish I could do this. I wish I had the intelligence and knowledge and resources to be like, I think the world needs this. I'm just gonna go and make it, and then to just be able to do that, and talk about it, and I just this is so beyond not only my skill set, but to be frank, like my comprehension. That's but I'm happy there are people in the world that can do this. Good for them.
I think the one thing that does need to happen with this is he needs to get a second S4 to put the battery pack in.
Yeah, has he talked about like how the batteries are going to get stored, or is that's still kind of a work in progress?
I think right now, for the most part, as I've read through the build, through the thread, it's really just been focused on trying to, a lot of attention paid to the battery, just ensuring the right choice there, and testing to see how long reasonably you'd be able to get that to last. But the focus overall is kind of on the individual parts and making sure they're picking the right items that will eventually come together to like this cohesive hold backpack build, whatever. But in terms of like how that is constructed, I don't think that's been developed too much. Right now it's just trying to figure out like, here are all the parts that make sense for this, and then once we've chosen those, we'll worry about sort of bringing them together. Because that'll be an interesting thing in its own right? Because you have like these batteries, which are a bit fragile and volatile. You have the build itself, which obviously is going to be emitting a fair amount of heat, and how do you sort of make that backpackable or portable in its own right while sort of keeping things well protected, keeping things well ventilated, all of this. Like that all by itself is sort of an interesting problem to be solved. Probably not as hard as some of this other stuff, but certainly something that would require a lot of consideration. All right, and with that, I think we're going to call it for tonight. This has been the third episode of Low Volume. Gonna have to come up with a show title. Actually, guys, show titles. What should we tell this show?
High temps are okay.
No, it's
Sweating balls is fine.
I agree. Sweating balls is fine.
come on, guys. This is a PG show. All right. Well, we'll figure out in the after show, I suppose. But this has been the third episode of Low Volume. I am Josh Ramirez. I've been joined today by the other three J's. That is James, John, and Jay. I am Josh. Thank you so much for listening. Catch us again in the next fortnight. Have a nice one, everyone. This episode of Low Volume is brought to you by Squarespace. Squarespace. They aren't actually sponsoring us, but every other podcast mentions them, so we figure we should too. Build it beautiful.
Linus is going to sue us for that.
Why?
That's my tagline. I'm Canadian. That's what he's
Build
gonna
it
say.
beautiful. No, that's Squarespace's tagline. They're like a beautiful. Can I just say I can count on one hand how many podcasts I listen to that aren't sponsored by Squarespace. And on the one hand, it's sort of like, oh, this is so awesome. They're pouring all this money to support all these podcasts I like. But on the other hand, it's like, dear God, I already give you all my money. Go away.
Squarespace is doing very well.
Yeah, almost too well. I used to recommend them and be like, people haven't really heard of Squarespace, but they're really quite good. And now it's just like, I have to roll my eyes every time I recommend it because it's like, yeah, it's still the best, but like, yeah. Ugh. Ugh. Ugh.